Hello there, Einstein. Welcome to our first instruction unit on mathematics, a very technical and detailed discipline, which is why I decided to give it the very official name of Basic Math Stuff. What we'll be doing in this lesson is really to get everybody talking the same language. We realize this might be a review and boring to some of you, and it might be useful to many others. At the end of the day, we want to start from a position where everybody understands and talks the same language. So the first part of that is, what are numbers? Well, numbers are really just a way to account. And we'll begin with sort of the most general number, which are called real numbers. What are real numbers? Well, real numbers are essentially any number you can think of. 1, 2, 3, 5,000, 0.6, pi, 2/3, so on. -1, a million. The only thing that is not a real number is, for example, the square root of -1, which we define as an imaginary number. Or one you're probably more familiar with and seen before is infinity. That is not a real number. But just about anything you typically think of as a number is a real number. And those real numbers make up a real number line, as we can see down here, which includes anything on our list from 1 to 5,000.6, or even in between pi and -1 and -pi, and so on. You may have also heard of whole numbers or counting numbers. Counting numbers are just simply 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, counting. A whole number is 0 plus the counting numbers, 0, 1, 2, 3, 4, etc. This is a whole number, which is something you will run into on the exam. Very much like a whole number, but slightly different, are what we know as integers. And again, you've probably heard that quite often. How does an integer differ from a whole number? Well, an integer just includes all your negative numbers as well. 3, -2, -1, and then 0, 1, 2, 3, and so on, going out ad infinitum, or infinitely, as we just saw, in either direction, positive and negative. So the difference between integers and whole numbers is the negative numbers. So this leaves us with real numbers, which is just about everything we know, more or less, excluding things like infinity. Subgroups of that include integers and whole numbers. So all that sounds very rational. Well, that leads us to yet another type of number, a rational number. What are rational numbers? Are they numbers that are very logical and make sense? Kind of like you, Einstein? No, not really. Rational numbers is any number that can be divided by another, or a fraction, as we'll later find in the fraction instruction unit if you're not already familiar with it. In this case, I use p divided by q, where p represents an integer and q represents another integer. So that could equal, for example, 1/2. That is a rational number. What then is not a rational number? Well, that would be an irrational number, of course. So that's got to be a number that doesn't make any sense whatsoever. Again, not quite. And remember, both of these are still real numbers. The irrational number just can't be expressed in the form of a fraction. And that might include the square root of 2 or pi, neither of which can be expressed exactly as a fraction. Those are examples of irrational numbers. You have probably heard of consecutive numbers, and all that means is they're just in order. So for example, in the case of whole numbers, consecutive whole numbers are 0, then 1, then 2, then 3, then 4, and so forth. It doesn't jump from 0 to 2 to 4 to 5 to 1. They're consecutive in order. So for example, consecutive multiples of 5 would be 5 times 1, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and so on. Those are consecutive multiples of 5. Yet another way we can think of numbers is even or odd. The only difference is even numbers are divisible by 2, or it's a multiple of 2. So 0, 2, 4, 6, these are the even numbers. They're divisible by 2, or they're multiples of 2. And note, 0 is an even number. 2 times 0 is 0. Odd numbers are the numbers that aren't even, quite simple. And that is going in order consecutively: 1, 3, 5, 7, and so on. So to continue with our idea of consecutive numbers above, consecutive odd whole numbers would be 1, 3, 5, 7, etc. in order consecutively.